Hi, Alvaro. Welcome back.
Thank you again and again for having me.
And again.
And again.
And Alvaro is, I think, not pronounced perfectly, right?
It is perfect
Alvaro.
right now. Alvaro.
Alvaro. Okay. Very good. So I was completely disorganized because this end of year, and it was crazy end of year. And what happened to me is I have like AHEX Live workshops. They are online.
Mm-hmm.
And usually I always forgot to announce the workshops. So they were just, I had always enough attendees, but I said, okay, I will announce them. And what I did, maybe at a conference on LinkedIn, and what happened was the last two were completely overbooked.
Wow.
And there is an Eventbrite and Meetup where you can register. And like in September, October, I said, okay, it is full, but almost full, but it will work. And then I got notifications that people are on the wait list, which is already a bad thing in Eventbrite.
Right.
So I closed the registration on Eventbrite, but I forgot that Meetup is open. And we are developers and the load balanced. And then, I get another batch of attendees on Meetup. And then at the end, I got lots of emails. They would really like to attend. And I had to manage this the last few days. So this was a stressful situation. Stressful. It was actually cool stress.
It is.
But, and it is good because it's a Java workshop, of course. Actually, if you're announcing Java workshop, you already know what happens, right? So you have to count with it. So,
exactly.
So on such.
That's great result anyway.
So there's nothing. Yeah, it was fun. It worked better than actually expected because it was highly interactive. So I got lots of questions and it worked actually well. So this was the thing. And what we did is maybe I told you this already, but in the first workshop, I was able to surprise the attendees by an hack, and I don't know whether we talk about that. So what I'm doing right now with LLMs a little bit, I'm experimenting.
Yes.
And a client of mine asked me, hey, what's about the structure and patterns, and do we still need it? BC and stuff like that. And then I thought about that and I said, okay, actually LLM have to know it because everything we do in Java is open source and all the patterns are ancient and there are lots of publications. So I think LLMs were trained on that.
Right.
And with that and maybe 20, 30 rules, they generate perfect Java code. But not only perfect, not Java code, they generate my code. How I think, with BCE structure, everything is perfect. And the prompt is minimal. You say just, create a new database component and you have it. And this is what I showed. And this amazed the developers. So they didn't expect such a thing because they say, okay, is Java still a thing or should we do Python? And the cool story is Java is 20-30% better or LLMs are better in Java generation than Python and TypeScript. And if you know the patterns on top of that is even better. So this was the last few days. And also another mistake at the beginning of the year or last year, I said I'm not very visible at conferences, and I got lots of requests. And I said yes, I can come, and because it was far away, and everything happened before and after reInvent. So I think I was at 12 conferences in the last month or something like this, and this was a complete time mismanagement. In this year, so it was a complete disaster from my side, but lots of fun.
Actually, but, on the topic of LLMs and code generation, there was an article published a few days ago that was very interesting, saying, okay, if LLMs are capable of generating good quality code and code that can be effectively used in production or whatnot, why do we asking them to generate human-like or human-amicable languages? Let's settle on high performance language. We don't care what the code. If the code works, why do you care about the language? Let's even say write in assembly, right? Or let's create a new programming language for LLMs. Now there's a caveat which was not widely mentioned, which is exactly what you said. Is like that theoretically is a good approach. Like if the LLM's code is so good, like why do we care? Well, obviously, we have to review it, but second, the vast amount of knowledge that is available for that upcoming language is non-existing versus languages like Java, where there's a really, really well-established field. And I think that's a key difference. But it's a good reflection anyway.
On April 1st, this was actually my idea since LLMs came around. So who cares about source code? Let's generate the machine code.
Yeah.
On April 1st, what I did, I asked LLM to generate bytecode. It's like Java doesn't matter. Why we need to compile? It takes too long.
Right.
And I asked LLM generate bytecode for Hello World Java, and it actually worked. And people say, yeah, this is amazing. Are you really doing this? And no, but it works. So I say, hey, LLM generate bytecode for Hello World, and then try to execute it with Java. So it worked. This was this year, April 1st.
Nice.
But I have another idea.
Okay.
So what I try to do is, and what I also found out is, you have to remember what you prompted a year ago, because nothing will change. You are in a project, you're implementing features, and you should be able to open the project and understand what's going on in the project. And in Java, we have vehicles like package info and JavaDoc and stuff like that. And my idea is to put as much business knowledge to the Java source code, so it is readable by humans better than before. And I force LLMs to do that. But the cool story is, if you open such a project with LLM, they already know what's going on, and they are very good in knowing about the knowledge.
That should work well.
So, and this is, I don't think if you had a machine code, you have to capture the business logic somewhere else.
Yeah.
Because there's not enough context information in machine code assembly or whatever. And with Java, because you can name methods and classes properly, is really good in capturing the business knowledge. And I think this is the way for the next few years, that you are, and for me, I'm a consultant or developer, so I write code. I have to, to be responsible for what I do. So regardless whether I use LLMs or not, sometimes I'm using, sometimes not, depends on the project. But I have to review the entire thing.
Yeah.
But if the LLM generates the same pattern, you are really fast with reviewing.
Right.
But if there is no structure, forget it. So so I would say I'm not really interested that the LLM generates a lot of code, because you will have to read the code. So the best would be, to generate one component, review, take ownership, refactor, refine, maybe tell LLM, never do this the next time,
Exactly.
do this differently, and this works pretty well.
Excellent. Yes, that should work well.
Yeah. What about actually our plan was, now back to the agenda, which is very strict in our case. 2 years ago, we agreed that StackGres is an interesting development, and this is like Kubernetes with Quarkus, right?
That's
so
correct.
Controller in Quarkus, with lots of Java source code, and we still had no time to discuss the thing. And I was actually surprised. So before the show, I look it up. It's like, this is actually, we already talked about it, which is not true. So what is StackGres?
Okay, so let's start by the name. StackGres has two parts, right? It's a stack on top of Postgres, or a stack for Postgres. So let me just elaborate here a little bit more first place. Postgres it's a great database that I love. I do it for my living. But Postgres is more like the Linux kernel. It's something that is powerful, but it's also small. And you need tools around it. It's let's say not batteries included. You need the Linux distro around it. You need a stack of components around it. And that is a StackGres. It's Postgres plus this set of tools that you need around to run it successfully. Basically, Postgres doesn't come with connection pooling, which is almost mandatory in Postgres world. Postgres doesn't come with an HA solution, which obviously you mostly want all the time. Postgres doesn't even come with a backup solution or a monitoring solution, right? So all these are separate tools that you can find in the ecosystem. But this is good and bad, because the ecosystem has a lot of choice, offers a lot of choice. It's good. It's also bad because some of the choices you may make are maybe not ideal or suboptimal, right? So it's good and bad. So StackGres, essentially, it is a curated, opinionated stack of the components that we deemed are the best ones for running Postgres in production, all packaged together and delivered to you in a single, let's say, installable package that is very cohesive. It's very simple to install, very simple to operate, and all fully automated. This is the
what is the package? Is this like a zip, or what is it?
It is a good question, and it's basically several things. Mostly, we'll say it's a Helm package as of today. You can also install StackGres in other ways, like classical curl pipe shell even though that's not really recommended because it makes upgrades a little bit harder. It also supports OLM, the mechanism for installing an OpenShift. But it's basically, let's call it a Helm package. But I keep using this package terminology because of how it all started. And so obviously
I have to interrupt you again. It's a little bit dangerous because I don't have I ever mentioned to you Oxide?
Oh, I'm very well aware of them. Yeah.
Yeah, because what they also have, they have a control API, right?
Yeah.
So you can start and stop virtual machines and stuff like that. Just like a cloud in your basement.
Yeah.
It was actually the perfect hardware for StackGres, right?
Oh, I would love to test the StackGres on their hardware, no question. I've been following what Oxide is doing for quite a long time, and they're also their podcast. I think they're doing a great job. We actually follow their RFCs. They make public every decision and decision process that they have, and it's pretty cool. I like that. They wrote one recently on how LLMs should and should not be used, which probably, if you haven't read, you'll find it very interesting.
I haven't. I was just I delivered some talks because also interesting. So this year, some of my clients asked me, can you review our cloud architecture on premise? And they say, okay, because public clouds are not secure. And I look at what they had, and I say, okay, but I mean, how you can tell, the public clouds are not secure because everything is encrypted. We have short-lived permissions. This is way better what usually you get, in a private data center. And they say, yeah, but our private data center is private. So again, if you're working with external people, maybe not that private, right? So it was an interesting discussion. So and this Oxide came from, okay, what you can do is, what would be the perfect setup for on-premise cloud and for public cloud? And if you would like to have an on-premise cloud-like environment, something like Oxide is great because you have, the primitives. You can stop, start virtual machines and automate everything. So you get a public cloud in your basement. So this is how, and they are also Sun people, some of them.
Yep.
Sun Microsystems, which is a similar mindset, right?
Obviously. I'm trying to do a little bit of a poor man's Oxide lately. I mean, it's not related really to Oxide because of the hardware. I'm just betting a lot on. I built some hardware. I'm making a small environment at home for let's say high performance. Need to do some stuff, and I'm betting on Incus. I don't know if you have checked it out. It's a fork of LXD. And LXD actually is not very well known in reality, but I think it's a great tool not only because of the idea of system containers, which are containers which feel like a VM. So you don't need to fake, what is my process? What is my init? Just SSH and get the console and you can start doing things. There's a systemd running. And it can also run VMs, and it's all with the same interface. So, and also application containers, like Docker-style containers. So you can run Docker-style containers, system containers, which feel like VMs, but they're much lighter, and proper VMs, all with a single command line interface configuration. And it's very convenient to have your own cloud, right? If you want to call it that way.
The LXD, it was a Linux competitor, right? So this was also no Linux, Docker competitor at the beginning.
Definitely in some ways. I mean, the concept is very similar. Actually, the line is a little bit blurry between what is an application container and what is a system container. But basically, the main difference is almost conceptual because they use the same primitive C groups and Linux namespaces, right? But basically, an application container is devoted to running an application where there's the parent P is that application that you're running with the system, the application container, sorry. And the system container is like, no, this is like a VM, except that the kernel is actually the host kernel. So because it's still a container, but it feels like a VM. And it's really, really convenient. You get started and say, start on Ubuntu 24.04. And that's it. And you get what looks like a VM that would in less than 1 second.
So you can, with what I'm surprised that you are not playing with the Firecracker a little bit more.
I've done it for sure. And I love it. I've wrote several posts on using and automating Firecracker. It's just also most of my workloads as of today are very focused on Postgres, unsurprisingly. And Firecrackers, there's only one thing is not good at, which is I/O.
Okay. This is not that exciting for you. So Postgres without I/O is less viable.
Exactly.
I would say.
Exactly.
But what should be interesting, Firecracker or not, something with cloud-like API. This is what interests me, that you have like a cloud API. And are you aware of the Sun API, Sun Cloud, the Sun Microsystems Cloud? They had a prototype; it never went in production. And they had REST interfaces, and they were actually cool because you could RESTful say create VM. You got back, created with the ID. You can create on this VM and MySQL, whatever. So it was actually really cool, and something like that would be interesting to automate the entire thing. So to consider, the cloud as a black box, so you can automate that.
Mm-hmm. Well, certainly Firecracker has an API. It's just that it's node local, right? There's no concept of orchestrator. Yeah. Actually, I toyed some code to do actually this.
Cool.
Yeah, never saw the light. I mean, that was not my goal anyway, but I toyed with this to create kind of an orchestrator which was calling the APIs of Firecrackers on different nodes. I also did similar work. I published a few blog posts. One blog post was quite interesting, was basically creating a 63 node Kubernetes cluster on a single machine. Mm-hmm. And for doing that, I was using Firecracker to create 63 VMs and then uniting all them as a Kubernetes cluster, right? Obviously, this doesn't serve any real purpose, but it was a great exercise. And there I was I was using basically shell script to wire it all together, but the shell scripts were calling curl to the API that Firecracker exposes. So
cool.
Yeah, I mean, conceptually similar. Very high.
So what you found out is that the StackGres doesn't run on Oxide now because you don't have the hardware, and the package you get as Helm chart, basically, which is almost like Xdoclet, 20 years old template engine.
Yeah, pretty much. But let me give you a little bit of a backstory there, because when we started StackGres, the main goal was not, there's this Kubernetes thing now, it's on the rising, and let's jump on and let's drink the Kool-Aid, right, and be on Kubernetes. That was not the reason, at least not for us. The reason why we came to Kubernetes was different. We were experimenting in the past with building this stack of components, right? The connection pooler, the high availability, the monitoring, the whatnot. And we were doing this mostly with Ansible because we believe in automation. We wanted to have all automated, right? And
you like Ansible?
Not dislike. I mean, it does its job more or less well. Okay. But here's the problem I see with Ansible. And we still do a lot of Ansible, but here's the problem with Ansible. I realized that after a few years that I expected to reuse code. I mean, me and my Java mindset were like, okay, where are my classes? Where are my packages? Where are my dependencies, right? And the reality is that not only we were not being able across projects and customers to reuse a lot of code, but we were copying and pasting literally and modifying. So Ansible allows you to create modules and to expose variables, but it's still limited. Right. And at the end of the day, it's much more practical, copy paste and readapt the code. And I was like, this is not the way to go. This is not correct. There should be a way. Can we deploy Postgres with all these tools, all this stack as a package? Again, coming to the concept of package, right? Anywhere. And the answer was like, no, we're using Ansible and modifying because every architecture is different. Every environment is different. And this causes differences. So then I started thinking, well, maybe the problem is the architecture itself, the environments. Can we virtualize an environment? Can we put an API on top of the architecture? And then suddenly, actually, that's what Kubernetes does. And for me, Kubernetes is an API-driven architecture, or an API that hides an architecture and abstracts away the compute, the storage, and the networking. So that's what actually we really wanted. So that's why we settled on Kubernetes. And that's why we created a package for Kubernetes, because we can program and automate everything regardless of where you're running. And that was the motivation.
You said Postgres and package and Ansible. And this reminds me of a newer project. Are you aware of System Initiative?
Yes.
And they are also storing the entire model in Postgres, actually. I think.
Yes, they've used Postgres for a long time, if I'm not mistaken.
Yeah. What System Initiative is like an automation platform, model-based infrastructure as code, I would say, right?
So yeah, it's very visual also, right?
And but you're right. Kubernetes is the most for you. Kubernetes is perfect. So for my clients, I'm not sure, but for a product, it is way to go. I mean, you have everything in place. You have etcd, a store. You can do whatever you like, right? So this is like the abstraction from everything, and you can achieve the full automation with Helm charts only.
So, well, definitely not. And actually, this is a very interesting point, because I see a lot of people still deploying Postgres on Kubernetes using just a Helm chart, or just even wiring up your pod. There was a very famous debate on Twitter that Kelsey Hightower started, saying, Kubernetes may not be the best place for running your databases, or you need to, what I say is, you need to twist Kubernetes arms a little bit. And certainly you need to do that. And doing it by hand, it's quite complicated. So this all needs to be also automated. So StackGres is technically an operator. So it's a software that runs, let's say, as a daemon within Kubernetes, and then manages the state of the cluster permanently. And it's all the time looking all your clusters, right? So it's all the time looking at what you have there running, and automates all the tuning that is required for actually and successfully running a database on Kubernetes, which is 100% possible. And there's no drawbacks to doing that, if and only if you have all this logic already built into an operator. So technically, StackGres is an operator, which means it exposes its own interfaces, or CRDs, custom resource definitions, which, to put it simply, are the easy YAMLs that the end user consumes. They're designed to be extremely easy, no Postgres knowledge required. So anyone could jump in and start using StackGres and create successfully production quality Postgres clusters. Everything is automated and hidden, meaning abstracted away from you, so that you need only to focus on how many instances, what is the size of the instances you want, and know how to wire this up with the HA component, and how to tune Postgres and whatnot, right? Which you can, of course, do. If you want to go deep, you can go deep, but in general, you don't need to do this. And this is all automated. So, yeah. And
this is the way to go, because I think without Kubernetes was almost impossible. So what the CRDs are is like custom commands, right? So you're extending the Kubernetes with own schema, more or less, and you have command which can be higher level command than the usual commands, and you can say StackGres up, whatever the command is, and it knows exactly in which order what should happen in the backend, because this is your encoded knowledge, right?
Yeah, let me give you an example. It's not only that Postgres requires this connection pooling, this monitoring, this high availability, this backup system, right? Then you need to configure all the config files, and each config file has different syntax. You need to understand that. You need to be an expert in reality. Now, one of the most advanced features that StackGres has is that it has integrated sharding. And sharding in databases, right, is when you scale out to multiple shards, multiple entities. You split logically your database into subsets, and each subset
like customized from A to C in this table and D to E to somewhere else, right?
Exactly. So now, and each shard also, because you probably want them to be highly available, right? So each shard is a cluster on itself. It's not even a single node; it's a cluster. So you can, with the StackGres, now say, I want a sharded cluster, and this will create multiple, not just one, but multiple cluster. Each cluster with all these characteristics, the high availability, the backup, the monitoring, the everything. And actually, sharding solutions typically require coordinator fronting everything, which is also another cluster for high availability, right? So basically, you can create a 60-node cluster, and this would typically take many weeks, if not months, of effort to an experienced already DBA with full automation. And now a user can do this with 13 lines of YAML code in a couple of minutes. That is the power of automation that is built in.
Why do they need 13 lines of YAML code and not a command in your operator?
So the usual way that people work in Kubernetes is via these CRDs. And so we have favored this approach. It is certainly also possible to have a command from the command line as a kubectl plugin. We haven't done this because we have favored the most, let's say, pure Kubernetes approach, which is, again, CRDs. Because when you have a CRD, which is a YAML file, you can do a more GitOps approach based way, in which, because this is going to be committed into your source code. So your architecture, your Postgres clusters will be on Git, and then you can do a PR.
But last time I played with CRDs, what I could do, if you, as I remember, if you apply the CRD, you got more or less a command which you can use to operate with the CRD. This is not like I had to do YAML. I could use a command and pass the parameters and then execute a CRD. I forgot actually what I did, but it was on OpenShift.
That was probably because there was a kubectl plugin that piggybacked on the same thing. So it really depends. I mean, technically, StackGres is quite unique in that we offer seamless operation with 3 different interfaces. So you can interface StackGres via CRDs, the most usual approach. You can interface StackGres via fully featured web console, and whatever you do on CRDs will be reflected in the web console and vice versa. They're interchangeable. And last but not least, the REST API. So if you want to do command line automation, it's typically more for integrations with third parties, or you want to use StackGres as a building block for your own cloud, Postgres as a service, or whatever. Then you can use the REST API for integration. But that is akin to command line too. But we haven't developed a plugin by itself, which is more like command line equivalent. But we're actually going to end up doing that for a next version that is also coming down the road of our technologies. But as of now, it's mostly CRDs because, again, you can keep them on Git. And this is very convenient to version control your infrastructure.
But the rest is interesting. It means I don't have to use anything. I could just automate complete everything with Java. So basically, because HTTP client, I can write a small app which manages my Postgres cluster without touching Kubernetes at all, right?
Yeah, exactly.
And the cool story is if we had Oxide, I could do both, right? Because if I create new cluster, it will actually behind the scenes, you can extend your stuff that it actually creates new VMs in Oxide. So this will be like, hardware and software hybrid.
Yeah. Brian, if you're listening, you were more than happy to have a cluster access and test it.
Okay. So your CRD, you're interacting with how to call it, YAML with new schema. And if you check somewhere, this to Git, it initiates a push, which can automate the entire thing, which is pretty cool. But it's already perfect because REST and console is perfect. And, you're right, with the YAML is way better to automate because you change something, it's committed. It could be even a GitHub issue. I would like to change that. There's the YAML, the entire flow. It is just perfect.
Yep. Now, the flow goes as you write the YAML file that you post it to Kubernetes via kubectl, for example, kubectl apply-f file. And Kubernetes actually, the problem is that it doesn't know how to handle these CRDs. CRDs custom resource definition is a custom object that we create. One of our CRDs is called SG cluster, which means StackGres cluster, right? Kubernetes doesn't know what to do with this. So Kubernetes has registered a callback and calls back to our software, to our operator. And this operator is the one that will handle these and will do all the operations, potentially calling back to Kubernetes API to perform action within the Kubernetes cluster. But the important fact here is that it's calling our own software. It's calling our own daemon, let's say, that is running on the Kubernetes cluster. And what is probably interesting, I guess you can correct me if I'm wrong, for today's audience, is that this operator is unlike most, if not all, but definitely most operators in the Kubernetes world are written in Go, which is the Kubernetes language. This operator is written in Java.
Which is remarkable, but not unusual if I know you. But and what's interesting, what I didn't know, there's a Google study, which I always show during my talks. First slide is that Java is actually faster than Go. This really surprised me.
It's not surprising to me at all. I mean, if you want a garbage collected language, why not go with the one who has 3 decades plus, correct me if I'm wrong, of innovation in what is the garbage collection algorithms and the JVM. It's hard to beat that amount of innovation and effort put into it. So if you want a garbage collected language, just go Java. If you want non-garbage collection language, then consider something else.
Yeah.
But garbage collection for me, it can only be Java. It's no way around it.
If I get your
JVM
package,
at least language, right?
StackGres, StackGres, and so to install this on Kubernetes, I will also have to install then the Java part, the Quarkus, which runs an operator. Is it like no?
No, not at all. Well, it's certainly written in. So it's written in Java, and it's a Quarkus application, right? Well,
this is GraalVM, I guess, right?
Yeah. It actually has 2 mechanisms of deployment that you can choose. The default one is GraalVM compile native binaries. So I mean, the Helm chart, the usual way to install it is the Helm chart, and the Helm chart already contains all the primitives required to install it, and you will just deploy. So StackGres is deployed as a deployment. So we'll create a pod, and inside the pod, it runs the container image that we provide, which is the operator. And this container image is produced in two flavors. One is compiled as a native binary, which is most people use, and the one that you will use by default. So you don't even realize that it's Java unless you want to. And Graal and Quarkus obviously does help a lot with the process of compilation to native with GraalVM. And we also offer a JVM flavor in case you want to have a more explicit JVM. Obviously, it results in a bigger container image. Note that there's no performance requisites here. I mean, the job that the operator is doing is responding to callbacks that happen at most every few seconds. So there's no performance. This is an orchestration control plane. There's no data plane. No Postgres traffic is flowing through this at all. And so it's not a big deal. So native image is a perfect fit for this. Actually, JVM is mostly for troubleshooting or other special environments.
But if I install, I have just plain Kubernetes, nothing, and I get your package. So you will have to download the container image, I assume, from somewhere. So do you have or are you building everything during the deployment on Kubernetes native? You know what I mean? So how the installation?
They're already built. So if you do a Helm install, the arguments for Helm install, install the Helm chart, that will create a lot of things. One of them will be a deployment. Within the deployment, it will create a pod, and the pod will pull a container image that is already pre-built by us.
Okay, so it would download from it, and this container image, Kubernetes knows is the operator image for you.
Exactly. Because it registers some callbacks with Kubernetes and basically tells Kubernetes, if someone is talking about SG cluster, SG Postgres config, SG sharded cluster, SG backup, and a few others that we have, then talk to us. Call me back.
Yeah.
And that's it.
And are you using the Quarkus shipped with the Kubernetes extension? So using the callback extension from Quarkus, or you implemented this by yourself?
No, it's we're using a lot of Quarkus features. The main question would be whether we're using so how we call Kubernetes API, right? Because we need to call the Kubernetes API. And there's, as of today, there's actually a project in Java to actually kind of build an operator SDK. Because actually, if you go look at the Go equivalent, there's an operator SDK with that name that helps you do a lot of the boilerplate of creating an operator in Java, managing CRDs and the callbacks and all that. But at the time we started, there was nothing like this in Java. So we started doing everything ourselves on top of Quarkus. But at the end of the day, the reason why you can successfully create an operator in Java is because a Kubernetes operator is no more than an HTTP client and an HTTP server. It's an HTTP server to respond to Kubernetes callbacks to you, and an HTTP client to call the Kubernetes API. And obviously, HTTP is something very simple to do, especially with Quarkus. So it works very well. But then you could have layers on top of that abstract away some of the most basic things, but they were not existing at the time. So the time we started bare bones.
What I used back then, Kubernetes client. I look it up. I think this was the Kubernetes client, and with that, I was able to talk to Kubernetes. And this is also what you use. And this was not available, you're saying?
No, Kubernetes client was. And actually, we started also after that using Fabric 8, which is a layer on top of it, right? And so we're using Fabric 8, but we're not using the more higher level construct that exists today that was not available at the time. But Fabric 8 already made things quite easy in this regard. So most of the logic is just about ourselves. It's not communication with Kubernetes, which is already more or less sorted out by Fabric 8.
Exactly. As a customizer, I just look it up. So because this was a long time ago, so I tried to automate OpenShift with that, and it worked. But then we find another way. And I think you use similar. There's a pod builder even. And interesting API. So, and you get event received. Exactly, you get notified by Kubernetes something is to do, and you call it back, and you can use the low level Kubernetes API to start pods, stop pods, do whatever you like, right?
Yeah. So there's two kind of callbacks, right? Let's say, or what is the usual way an operator like this works? It's basically it's running permanently. That's the main difference, for example, with Ansible. Ansible is a one shot, right? You just deploy something and that's it. But if there is some drift, if something fails, if you need to create something, you need to act on something, there's nothing else running. it's gone, right? So here we have something that is permanently running, which is the operator. So the operator does two things. One is to run what is called the reconciliation cycle. And the reconciliation cycle is basically, I will wake up myself every, let's say, 10 seconds, which I believe is the default. And I will check what the user was asking me to do, what the content of the CRDs, which is the intent in Kubernetes, right? And what is the real state of what I have on my cluster. And if there's any difference, I'll take actions. And the other thing is reacting to Kubernetes events. So whenever a user creates a new CRD or deletes a CRD or edits a CRD, Kubernetes will call us back and say, hey, there's been this change, your call. And then you will take actions. And those actions are typically calling Kubernetes API. Could also be calling our own pods. So we have also an operator to pod communication channel, because sometimes we just need to act directly within the container to perform Postgres operations, for example, to restart Postgres or to install a new extension or to perform a minor or major version upgrade. All these operations are fully automated and coordinated across pod creation, pod operations, which are handled via the operator calling Kubernetes API, as well as talking to our pods and performing local operations. We call this a pod local controller, actually.
But the reconciliation processes, are you only in charge of the your own CRDs reconciliation, or you are in charge of the entire Kubernetes then? So
no, only our own CRDs.
CRDs. That means if someone would like to have resharding, it submits the resharding YAML, and then you see this is, there's no resharding in place in the Kubernetes cluster, but one is requested, and you try to reach the state, right?
Yep. Exactly.
And how complex is the operator? Is it like 1 class 2?
Well, okay. This can be a little bit misleading, but as of today, it's over 250,000 lines of code. Okay. Now, to be fair, there's not that much business logic there. A lot of the percentage of lines of code comes from Java, let's say POJOs, because this also predates records time. So, yep. Now, if we would rewrite everything as records, it would be much, much, much better. But just think that our CRDs, some of them are quite extensive and they have like tons of properties. Like the basic thing, you can do a few lines of YAML and you'll be good. But if you really want to deep dive and you really need to fine tune and configure a lot of things, there are certain CRDs where we had to embed other existing Kubernetes objects, not to reinvent the wheel. And those are huge. So we end up at some point with the problem that our CRD definition was more than 1 megabyte, and etcd cannot store that. So we had to even cut that a little bit. And now all these properties, all this hierarchy of data, we need to map them to objects in Java, obviously, right? And because we were doing this pre-record time, it's plain POJOs, and they take a lot of lines of code.
What it's interesting in your case, but in my projects, what we decided actually twice. In a recent project where this was actually my suggestion, is where there was extension API, which was not very good, and we had to write tests first against the API and then migrate the entire thing to Java. And and instead of doing JSON binding with JSONB or Jackson, we used the JSONP, which you can. It is basically a hash map, and you have a JSON path, so you can pick whatever you need, and you don't have to map everything.
Yeah.
And I did it in another project as well, because we had to support a lot of versions which were different, and then you would end up having several Java objects which look identical. There are small differences in them, or you have one Java object and try to map it, but then you have the problem. Then the older versions maybe don't have all the attributes, or the structure is a bit different.
Right.
And then we used the JSONP, so we didn't have any data objects. But the problem, of course, we had to test more because the mapping was not as obvious. So the mapping, you had to pick, the right state from the hierarchy of objects, but it worked well.
Yeah, I mean, there's definitely automation right now to kind of create these files and maintain these files. It's not ideal. If we're using modern Java still, but again, we started 5 years ago, right? So, is it worth right now to rewrite as records or anything like that? Probably not, because we already have automation to build the Java objects from the CRDs. But anyway, generates a lot of code. So business logic is definitely not 250,000 lines of code, but it's a big project. It's a big project.
So it means your best practices, how a cluster is run, is encoded in Quarkus, basically. So it's the brain of the project.
There's obviously several sub-projects, right? So there's the operator itself, there's the Quarkus, the pod local control that I just mentioned before. They're parts of the same thing. They coordinate, but they're separate, right? They're separate, let's say, binaries.
Pod local control? What is the pod local control?
So the pod local controller is a sidecar that we deploy always with every Postgres running instance. And it's responsible for performing actions that are local to the Postgres cluster. Among them, the most important them is in the extensions. So this is actually a very interesting topic. I gave actually a talk at the KubeCon about how we deal with extensions. And it piggybacks on our previous chapter with Dozer, right?
Because dynamic containers.
Yeah. So the problem is essentially, to try to summarize it, it's basically that Postgres has this model of extensions. They're like plugins for the browser, right? And many users want to use multiple extensions. Now, if you want to support 200, 300 extensions, what do? Do you build a container with 200 or 300 extensions? Well, other than the size, which is already not a good idea, extensions normally are developed by third parties over GitHub, and they're a bit random, which means that they could have security vulnerabilities. So if you package 300 of them on a single container, you're basically bringing a lot of vulnerabilities. And so it's not a good idea. With dynamic container images, we're solving the problem perfectly, because you can create real-time a container with exactly what you want. But because this technology was also not available by the time we were constructing StackGres, then we did something in between, which is we start with a container without extensions, but then we have this local pod controller, which is, again, a sidecar. And whenever the user modifies a CRD and says, I want to add this extension, it will detect this. The operator will receive the order, will talk to the pod local controller, and the pod local controller will initiate a download from our extension repository, unpack the extension, apply through all the cluster, and bring it on top of the existing container image runtime. So you essentially get the extension there. So this is the role of this pod local control, is performing actions like this. Also, the restart operations, the minor version upgrades, which are operations that are also automated, they need to run commands within the Postgres container. And so they're delegated to this pod local controller, which by itself is a separate Quarkus application.
Which is interesting concept. And by the way, as you explained that, this is actually, I thought, it's not about Postgres, right? You could use this to build whatever cloud you like. So you could have, pods of Quarkus services, and this sidecar could care about metrics, JFR events gathering, for instance, Java flight recorder events, and reporting back upgrades. It could be actually self-managed cluster, right?
We are actually building a new product right now where we are actually elevating this exact pattern you're mentioning. We have something per unit, let's say like this pod local controller. We have a local controller per node, which performs local actions. They're obviously related to Postgres and databases, but could be extended to anything else. And then they're not a standalone. They have a control plane, and this control plane controls them and tells them to do the actions, sometimes isolated, sometimes coordinated. So instead of running remote commands, for example, in many operators, just do call the Kubernetes API to tell Kubernetes to run a command within the container, which it's kind of okay, but it's much better to actually you communicate with your control. The control plane communicates with the control node, and then the control node takes the actions locally by running whatever commands is required locally, or via code if it's possible to do as code, right? And so this pattern, we are elevating it. We're defining a set of gRPC communication between the control node and the control plane, and which is actually, by the way, we call it inverse. Meaning that it's not that typically each of the control nodes will be, if you would do this or you would design this, typically you will make them a server. So the control plane is a client and then talks to the nodes because they're exposing a server. For example, this is how Prometheus works. And we, instead of are doing the opposite. Each control node is a client, and the only server is the control plane. So the control nodes call the control plane, register themselves saying like, hey, I'm here. I'm ready to be managed. You manage me now. And then they open a bidirectional channel of communication via gRPC, a bidirectional stream, so that they can both exchange orders. But it's mostly the control plane sending orders via this bidirectional channel in, let's say, reverse order. That's why we call it inverse, to the controlled node. And this way, actually, it can even traverse firewalls, traverse boundaries of networks, because it's just an outgoing HTTP connection, what the controlled entities are doing.
Because the entity from outside initiate the connection first, right? So this is...
Yeah, exactly.
Yeah, are you aware of Genie?
No, what is it?
Java Intelligent Network Infrastructure.
Okay, no.
This is, you have to do some research because it's an old project. And it lives somehow is Apache River. It was open source. And Genie was one of the things. It was a huge push to Java. It was around 2000. Maybe it ended 2005, the popularity. But Genie had what you described now, plus one more. And this was the concept of leasing, which was genius. I borrowed it a couple of times. So it would mean that I'm, as a client, I'm registering to a central hub, but I have to re-register every 10 minutes. And if I forget, then my lease disappears and I get automatically garbage collected. So it's like self-healing. It means the boss knows, okay, he's no more alive. So this was this was the core concept of Genie. And other than that, it was this what you're describing, not with gRPC, but with RMI, remote method invocation in Java back then. And And actually, I was hired once to introduce also Genie architectures at Stock Exchange in Portugal, actually. So this was and Formula One had also Genie. McLaren, I think they use it for real time. So look up the patterns; it could be helpful. So the old patterns from Genie and Java Spaces, and Java Spaces was like the NoSQL distributed NoSQL, which was transactional. Based on Linda. So Genie, so just concepts is actually pretty cool. Yeah. Genie and Java Spaces. This is your homework assignment, for the next 2 years.
Excellent.
Yeah. And yesterday, one of my attendees asked what they have. They have KVM cluster. So we discussed Java agents. And you know what the reference implementation of the official Google agent-to-agent protocol is?
No.
Quarkus.
Nice.
Yeah, but what you're describing here could be an answer yesterday to the NTD, because he said, okay, they have several algorithms, and one algorithm is to put as much as possible to the hardware as pods or whatever they call it in the KVM machines, or the other one is to balance the cluster. So they have various strategies, and they wanted to use agents or LLMs to do that. And I thought, okay, this would do a little bit. I don't trust the LLMs too much for such a things, because it can go. For instance, right, the best balancing you can achieve if you delete, all the pods, nothing runs is perfectly balanced. For instance, right? For instance, this would be one concern, but they have the data.
Already.
Yeah, they have the data, and I say what you could do. Of course, you can have an agent which observes the data, and could, for instance, generate the code for the cluster management. And then you can test the code and then apply the code, and then the agent can observe whether it improved or not and improve on the code base. And this is your choice where you put the code in production. In your case, you have it already. So what you only need is in the middle, in the core of your 250K lines of codes, have like a fluid kernel with a plugin, where you have an LLM which runs outside, watches all your sidecars and the traffic, and thinks whether anything can be optimized in your environment, and then can ping you and create a GitHub request with the new algorithm. You can review this. Hey, this looks good. Then say, go ahead. It is compiled, tested, and automatically installed in the operator.
Yep. Yeah.
So you could have, continuous improvement of the cluster with LLMs without any risks. Because if you review the code, this is your review say, hey, this is maybe a good idea, right? So this is I think could work in such environment.
Yeah, there's ongoing efforts in this direction, and one of the good things that we can do is that, StackGres supports like a really wide array of features in terms of what is operational required for Postgres. Is probably the most advanced operator, I would say, by far existing. And one of the things that is very interesting is that when you're allowing an LLM to analyze something and then propose something, even if it's not directly acting on something, is that you need to test it, right?
Yeah.
And something like spinning a cluster. For example, one of the features that StackGres supports is using the underlying snapshot mechanism for disks on Kubernetes. So you can take a snapshot of a running database and use this to create a clone and speed up a clone cluster so that it will nothing affect production, and then test whatever change you want to perform there on this clone, right? Clone based. There's a company actually called Postgres AI, for example, has done a great effort in automating the process of creating Postgres clones for this. The same purpose, testing something. And now with LLMs, I think it's more critical because databases are critical part of the infrastructure. It's something that most DBAs will say, you will not touch this ever, right? Unless I approve that. So that's fine and understandable. But then you may create a test environment with similar data, actually the same data as production. For example, if you restore from a snapshot, and then you can use it to test whatever, potential improvement LLM came up with. So it's a more conservative world, but it's something that we can use these techniques to actually test things, and then actually you can get on the PR like, I spun up a cluster and I tested with real data, and it kind of improved this whatever metric you're trying to improve. Then it's just review are easier because you already know that.
And even could be, not necessary even code. It could be simpler that your code is parameterized and all the parameters are coming from outside, which can be suggested by LLM. So like, look, if you change this parameter, I think it could work better because, and then it's less risk, right?
And we have actually a lot of Java code as part of the operator to validate all these parameters. For example, just to give you another idea, when by default you don't need to tune any Postgres config. A Postgres config can get complex. There's more than 300 parameters to tune there, right? So much that we actually, at my company, we created another project, which is also written in Java.
How good are you with the config properties? Are you still...
PostgreSQL call.nf, which is like the Postgres config file, PostgreSQL.conf, but shifting the dot to positions to the right? And this is also, by the way, it's pure HTML, the output, but it's written in Java, the backend that processes all that. And however, we apply tuning by default in StackGres. So if you create a cluster, you don't need to specify the tuning, and it's already well tuned by default. But if you want to tune the config, there's two approaches, right? What I've seen in other operators, like, okay, like you can embed into the CRD your raw config, and we'll just apply it blindly, right? In StackGres, we don't do that. Let's say we objectify that raw configuration. So it's like a high-level YAML construct. And then we validate every parameter name, parameter ranges, and whether the parameter is allowed or not. And this is, again, another subcomponent of StackGres, which is a library to validate all the, for example, a Postgres config. And so, if we would allow a third party, like say, like an LLM, to try to propose some parameters, that will still go through the same validation. And we will say, no, you're proposing a value that is out of range. Postgres does not support this. The minimum value is 3. Whatever, right? So we have code for that, so it makes a lot of sense.
There's like a syntactic correctors, not semantic as a little bit as well, but you cannot.
It's both. It's both.
So you have the StackGres is the operator and the local pod controllers, you told, and the local pod controllers are talking to the operator is more like design choice because it's easier to talk locally. And this is StackGres, right?
Yes.
So after 2 years, we reached the goal. This was the origin plan. We talk about, the Java kernel. Yeah. And are you still happy with the Java choice? Or you said, no, if I would use, I don't know, Rust, I would be happier? Or
no, not at all. I think it's been a great choice. I mean, we love Java. We are quite experienced with Java. And we wanted to move fast. And actually, this was obviously it was a debate. First time we started this, well, Rust was almost non-existing by the time we were started with this. This was not mainstream. And I was like, okay, what do we do? Do we do Java here, where we need to do HTTP client? Start with HTTP client to communicate with Kubernetes. Later Kubernetes client, later Fabric 8. But at the time, it was like, yeah, can we do HTTP bare bones?
How you picked Quarkus, actually? Why you knew that Quarkus could be helpful?
Well, main reason was actually GraalVM, because we wanted native binaries from the get-go, right? And
okay.
Yeah, Quarkus made it very simple.
And why you wanted to have binaries? Because if there is container, you could ship Java. It would be a big difference, right?
Except in size.
This is download size, right?
Yeah.
And how bad is it? So if you, how big is Quarkus on VM, the container size? If you do it, you optimize that? It's like 200 megs or something like this, right?
It's more because we use all the dependencies. So it's like several hundred. I mean, I don't know the numbers exactly, but maybe
this is big.
500 megabytes, right? Versus the binary, which is also not small, but we're getting like an 80 megabytes binary.
Okay. And you already applied all the optimization to GraalVM, or is before that?
I think so. I think it's quite optimized. Okay. I mean, the difference at that point between 80 megabytes and 60 is not going to be a big deal, right? But from 80 to 400 or 500 is definitely a big difference.
But interestingly, yesterday I upgraded Cloud Code. This is now binary, I think. And the binary is like 200 megs. And this is terminal application. And I think even implemented Rust, it looks like. It was Node.js before. And now I think it's native. But regardless, for a terminal app, 200 megs is actually a lot.
It is a lot. Yeah, I imagine it's all the dependencies. At the end of the day, dependencies end up eating a lot.
But 80 megs is not big for an entire operator.
It's not big. No, it's not. It's pretty good. That's why. I mean, it's not our concern as of now to optimize that further. We again, for our new project, we need to optimize a little bit more, because we are running all the components within the containers, and some of them are designed to be on purpose very, very small. And that's why we've been experimenting with the smaller sizes, which, by the way, you helped me connect with some people with the GraalVM community. And we did some improvements there thanks to their help. And we're now targeting a smaller GraalVM native binaries, very optimized. And on top of that, compressed with UPX, which also reduces the size further. But for this particular case, not that much important. So at the end of the day, we decided to go with Java because there was the option to go with Go, and there was plenty of documentation. There was the operator SDK for Go at the time. And it was really easy to scaffold something and get started in Go. But we had zero experience with Go and plenty of experience with Java. And the bet was like, I bet that in a couple of months, we have already passed this initial scaffolding that Go will bring us. And from then on, we'll be able to go at a much higher pace and a much faster innovation pace. And that was exactly the case. We started more or less at the same time.
Are you thinking that Java is more productive than Go? I don't know. I have no idea.
For us, much more. No question. Okay. But actually, I have a data point. There was another operator for Postgres that was starting more or less at the same time as we were, and they chose Go. They were a bigger team and backed by a larger company, but they were not Go programmers. Also, they were more like Postgres DBAs turned into programmers. And we were able, with a much smaller team, to add many more features and more advanced capabilities to StackGres, just because we were already senior Java team.
This is also my observation a bit, because if you write simple Java code, you are really fast.
Yeah.
The problem Java had historically is because of the exaggerated, architectures where everything has to be decomposed. But you can have the same situation in Go. If you get crazy architect in Go, I'm pretty sure you can also build there 17 layers of abstraction. You don't need Java for that. And I always curious, because I like Java a lot, and this makes me not objective. But I have the feeling that I'm really fast with Java. So I cannot imagine if I would use different language, I would be even faster, because I spend time thinking about problems. And if I know the solution, I have the code in no time. It's not like Java holds me back. It's more like the real world problems are actually the friction, right? And if you know what to do, then sit down, write, and it works. And with Java, we get a great tooling and multiple options. Actually, is also cool. We can use Maven or not, we can use Gradle or not, or we can use Leiden or GraalVM. So you have multiple options to achieve the optimum. Or you just go with stock Java without any optimization. It's still good enough. This is actually the cool story.
And I think actually tooling is key. I haven't seen any other language. The debugging experience in Java, haven't seen in any other language. End of story. And at the end of the day, you spend a lot of time debugging. Nobody writes perfect code at first, right?
Yeah.
I mean, at least I don't do.
Not even CTO.
No, you have to debug a lot, and debugging experience in Java is just a pleasure. It's just amazing, and I haven't seen anything like that in another language to date.
Pretty cool. So, of course, I have to invite you back about the new stuff, StackGres without Postgres, of course. And I wish you all the best, and it was always fun. And by the way, just briefly, I like your Frame notebook, and if I will need frame or framework,
framework.
I always don't like to tell framework, because in Java frameworks all the time it's like, it cannot be right. This is probably frame, not framework, but it's a framework. Okay, it's a great machine, and I saw this at the conference in reInvent, and it is the build quality. I was surprised by the build quality. It is really solid, and I would say absolutely comparable to Apple hardware. This is my what I saw. It was really nice, and it is already working.
Yeah, it is already working, and I'm gonna be publishing a series of blog posts on how I've done all the automation to get from zero to everything as I want in a few steps. In case you're interested.
As I saw the machine, so my initial instinct was, I buy it today. But if I will do this, I will be completely destroyed right now, because my time schedule will be even worse. Because, I have my Mac just works. I would get Linux. I would try to make it work. I will lose days with lots of fun, and all my clients will call me crazy. It's like, what are you doing? We have some deadlines here. And if something, I would need a different machine. I think this is the option right now. I think.
Yeah. And this is the reason why I'm automating this, because I've suffered this problem so many times. This is shameful. I got a new laptop a few years ago, and because I never had a couple of days in a row to work on it, I barely used it. I kept using my old one. And this is very shameful. I said, I need to put stop to this. So this one, I'm not fully done with the automation yet, but it's in a really good shape right now. And this is a job that I'll do once in my life. I mean, then I will upgrade versions, whatnot, right? But essentially, and also because if I lose my laptop, and I also suffered a few months ago, where I fortunately got my laptop stolen, and nothing happened to me. It was just misplaced and then stolen. Then I want to be able to be back up. My goal is to be back up in less than 1 hour. And it's actually right now like 5 to 10 minutes to reinstall everything, including even updating the BIOS. Everything.
And this you will describe in your series of posts.
Yes. It's basically going to be a series of 3 posts. First is called the installation of the OS automatically with Ubuntu Auto Install. Less than this new computer, it takes like 2 to 3 minutes to install everything. It's basically on the installation is coded in one YAML file. You start the installation, say use this YAML file, and then 3 minutes later you're done. Then
you like actually YAML? I have to ask you. I will always I hesitated a little bit because of.
Don't quote me on this. I don't mind, but don't quote me on loving it. Right? Yeah. Okay. Then I use a second stage, which is a lot of Ansible. Again, not super fun, but it just works and does the job to post install stage, install a series of packages, partition further, install CFS, run everything on the CFS file system, create all my pools, encrypted pools, non-encrypted pools, everything within the laptop. Yes, everything within the laptop. And then install Nix. And then the third stage is everything with Nix to install the rest of the package that I really want to have for my computer.
Cool. So you are the proper CTO, you spend time with the right things. What is the blog? What is your blog?
Even worse, the CEO.
A CEO. Oh, yeah, this is the best CEO I know so far.
Or the worst.
Hey, what's your blog?
It is, well, actually, I would say my personal page, aht.es.
EHT for
That's my initials, Alvaro. Actually, Alvaro Hernandez Tortosa. That's my full thing. So AHT Alpha Hotel Tango.es is in Spain. That is my personal page. I blog on several places, but they're all linked, or eventually will all be linked there. So aht.es.
Okay. And to listeners, to increase the pressure, either we will do screencasts or we would like to demo, this StackGres, how great it is. So there will be a screencast, but it's really hard to deliver here on the podcast because it's audio only. But we have to think about something which is appealing to the.
Yeah. I think that will be a good thing to do. We'll do.
Yeah,
for sure.
Because thank you a lot, and see you next time.
Thank you indeed. Thank you for having me again. Always a pleasure.